Hey folks, Mr. Dell here. We are looking at rules of exponents, simplifying expressions that contain exponents. So this is a problem that I'm taking from CPM's Math 2, High School Math 2, and this is from section 6.1.1, specifically number 6-8. So we'll simplify these, and then I'll show you the rules that I'm using. So it says simplify each of the expressions below. Then it says your final expression uh, should contain no negative exponents and no parentheses. So we'll talk through that. So let's start with the first one, A. What we have is negative 10, a to the negative 1, and all of that is multiplied by 2a to the fourth all times b. So when you think about this, really all this is it's a string of multiplication. It's a negative 10 times a to the negative 1 times 2 times a to the fourth times b, right? It's a string of multiplication. And we know that multiplication is commutative and associative. So that means we can kind of move things around, multiply out of order. So that's what I'm going to pair things up here. This is negative 10 times 2. I'm going to put those together because those are the coefficients. And then there's this a to the negative 1 times a to the fourth, right? And then times b at the end. So I put them together so you can see, well, I'm going to multiply those now. Now I can multiply the coefficients, the two numbers. The negative 10 times 2 is negative 20. And then when it comes to the a's here, we have a to the negative 1 and a to the fourth. Well, when you multiply like bases, you add the exponent, so it becomes a to the third. So I have negative 20, a to the third, and then the b is just by itself. So that right there is my answer, my simplified answer. No negative exponents, no parentheses. But why did that work? Well, let me explain that. So one of the rules with exponents is when you're multiplying bases, like bases. So let's say x to the a times x to the, let me do that, times x to the b. If I multiply like bases, my bases are those are the exponents. When you multiply like bases, what happens is the base doesn't change, but then you add the exponents. That's one of the rules of simplifying exponents, okay? So let's look at the next one here, part B. Part B then says, okay, now I've got all of this in here, this 3x to the fourth y, all to the second. So that power of 2 applies to each one of those. So it's really 3 to the second, x to the eighth, y to the second. Okay, so and then I can simplify that further. 3 to the second is 9, x to the eighth, y to the second. So there's my answer, but why did that happen? We know another rule, and I'll show the other rule. The other rule is if I have a base to an exponent, x to the a, and I take that and I take it to the power of another exponent, b, so x to the a all to the b is the same thing as that base stays the same, and I multiply those exponents. It's a times b. X to the a all to the b is the same thing as x to the a b. So this is another exponent rule that we have. So going back to my problem, this 3 has an exponent of 1. Whenever there's no exponent on it, it's really a 1. That y has an exponent of 1. So what I did is I took that 2 and just kind of distributed it to each of those exponents. So that's why it became 3 to the 2, because it's 1 times 2, x to the 8th, because it's 4 times 2, and y to the second, because it's 1 times 2. So that's where that came from. Okay, so part C. Part C now I've got this division, simplifying with division of bases and exponents. So first of all, the constants here, the coefficients, I should say, those can divide because it's a 4 over 2, right? Remember, when everything's all multiplied, when everything's all multiplication, we can treat this separately here. So we've got 4 divided by 2, so that's going to give me equal to 2, 4 divided by 2. And then z to the fifth divided by z to the negative 2. That actually becomes, that's just a 2. Make sure you can see that's a 2. It becomes a z, and I'll put a little mark in there so you see that, a z to the 7th. So there's my simplified answer. And why is that? Well, let me show you another rule. Another rule is if I take x to the a and I divide it by x to the b, right? I have this same base, my x is my base, but different exponents, and I'm dividing them. What I get is I actually get that same base stays the same, and I subtract the exponents. So x to the a divided by x to the b is x to the a minus b. That's another exponent rule that we have. Okay, and so notice what did I do here? I took first divided the coefficients, the 4 and the 2, but then I had this z to the fifth minus -2, right? I took those exponents, I subtract them. When you minus a negative, it all becomes addition there. So it actually was z to the seventh. Okay. All right. I hope that helps.